Okay, in this question for the part 13 with part B over there, I am saying the satellite is in the orbit of with the above the equator. Deduce whether the satellite would appear to be stationary above the surface of Earth. Period of rotation of Earth is being given as 8.64 multiply 10 raised to power 4 seconds over there. For this purpose, I will simply say here, we will have to take centripetal force which is responsible for any object to move on a circular path over there, should equal to gravitational force, which I'm taking here GMM over R square according to law of gravitation over there. I'm equating it equal to centripetal force, which I can say I can take here mv square over R, which I can take here if I take this tangential velocity in the form of angular velocity relation over there. I'm saying m r square omega square, and I can equate it divided by r over there. Then I will say it is m r omega square over there. So I'm taking here m r omega square. And if I arrange it from here, then I will observe how can I make omega as a subject over there. 1m small m is going to cancel over there. R is going to take omega cube, and I'm taking this omega as a subject. Omega square is equal to gm over r cube. If I take square root on both sides, then my omega is equal to gm over r cube, taking the square root over there. If we place all of those values over there, then we can say here that the values should be placed in the form of omega is equal to 6.67 multiplied 10 raised to a minus 11, and mass of earth, which is given in the previous part, that is 5.98 multiplied 10 raised to power 24. This is the mass of earth over there. And if I talk about the height above the surface of earth over there, that was taken 4.22 multiplied 10 raised to power 7. I will have to take its cube over there. Then I will say here divided by 4.22 multiplied 10 raised to power 7 whole power 3 over there. And I will also say that I am taking the square root over there. And if we take the square root, let's check what the value is coming over there. First of all, square root introduced, fraction introduced. Then he is saying 6.67, 6.67 multiplied 10 raised to power minus 11 there, and multiplied by 5.98 multiplied 10 raised to power 24 over there, divided by, you can also add the units like kg and Newton meter square per kg square for gravitational constant, 6.67, like this capital G over there. You can also use the units over there. And here I will take the omega as unit for radian per second over there. All right, let's go for it. Here he is saying bracket start 4.22 multiply 10 raised to power 7 bracket close whole power 3. Let's check what the answer is coming. That is 7.29. I am rounding it off. 7.29 multiplied 10 raised to power minus 5. 7.29 multiplied 10 raised to power minus 5 radian per second. Omega is angular velocity having its unit as radian per second. And while writing these quantities, you can also add here, I'm giving the different color over there. You can write here kg, you can add here meter, you can add here for a capital letter G, gravitational constant like Newton meter square per kg square in the form of units over there. And at the end, you are writing it with omega. And now if I go with the calculation of time period from here, then I will say that the time period is coming, T is equal to being taken 2 pi over omega, 2 pi over omega. As we know, the angular velocity is 2 pi over T according to time period. The same case you can use over here, 2 pi over 7.29 multiply 10 raised to power minus 5. Let's go for this. Let's check what the time period is coming for it. So I'm saying here 2 shift pi divided by answer will equal to 862 multiply 10 raised to power 4. So I will say here it is coming with the value 8.62, 8.62 multiply 10 raised to power 4 seconds over there. So if I talk according to the time period which he has given to me, I can say the value of t will be, this is a consistent conclusion that can be made over there from this time period. So it will appear approximately stationary if you observe that period of rotation of Earth about axis is 8.64 and you are getting 8.62 multiply 10 is power 4 multiply 10 is power 4, then I can say here when I am taking the centripetal force which I have taken from the above form to in this form, centripetal force is approximately equal to gravitational force, then we can conclude that a satellite would move with the Earth and appear stationary above the Earth's surface, and it appears stationary above the surface over there. All right, let's move to question number 14 there, where he is saying that astronomers uses a variety of methods to determine the distance to astronomical objects. Explain why trigonometric parallax can be used to determine the distance of objects that are relatively close to Earth over there. So the reason is the parallax angle decreases the further the object is from the Earth, as the parallax angle decreases over there. Parallax angle decreases, and we can say when parallax angle decreases, the further the object is from the Earth, as the object is farther from Earth over there. And I can also conclude over there that the distance object of the parallax angle is very small, so the measuring instrument is not sensitive enough over there. So the measuring instrument which I am using for measuring the distant astronomical objects over there, so the measuring instrument is not sensitive enough. So the measuring instrument is not so much sensitive. You can give any other reasons if you keep in your mind. You can say that the measurement is not accurate enough, or you can take percentage uncertainty is too high over there. You can add as the reason which you want to add for that one. Okay, now he is saying for the objects that are not close to Earth, the method of standard candle is used. What is meant by standard candle? So standard candle is a stellar object of known luminosity. Okay, what I'm saying, what is the standard candle? It is a stellar, it is a stellar, it is a stellar or object, it is a stellar object of known luminosity. Noun luminosity. So remember, just try to memorize the definitions which are added according to topic over there. Luminosity, NOSITY over there. So this is what is meant by standard candle. Basically, just you can add any definition if you have in different words over there. Describe how the method of standard candles is used to determine the distance to a distant star of cluster. So standard candle is basically located in the star cluster, over there. What I am saying here, just note down standard cluster or standard candle is available, is located, is available, located in the star cluster, in the star cluster over there. When it is located in the star cluster over there, and then I can say that the intensity of radiation received from the candle is measured on Earth. Intensity of radiation received from the candle, received from the candle over there, candle is measured on Earth, is measured on Earth over there. And then we can add over here that as we know, inverse square law is used, and then inverse square law is used with luminosity of standard candle, with luminosity of standard candle over there, and to determine the distance of the star cluster. To determine the distance of star cluster, distance of star cluster over there. So this is the way how we can say, how can we can describe the distant determination of the distance to a distant star cluster over there. For this one, I will say standard cluster candle is located in the star cluster. So intensity of radiation received from the candle is measured on Earth, and the inverse square law is used with the luminosity of the standard candle to determine the distance of the star over there. So I will say here radiation flux for intensity is acceptable, and don't go for calculation over there. It is only for determination. And if I mention here the inverse square law according to intensity, then I will say luminosity over pi 4 pi d square over there. So d is basically the distance, and intensity is inversely proportional according to inverse square law over there. Okay, then we will have to move to question number 15 there. Okay, here he is saying the body of racing car is connected to a wheel of racing by the suspension system. All right. Here it is showing the wheels, suspension system, racing car body. When the body of the racing car is displaced vertically from an equilibrium position, the suspension system causes the car to oscillate. So shock absorber like that with the simple harmonic motion. State the condition of an object to oscillate with simple harmonic motion over there. So you can add any condition that acceleration is always directed towards mean position, and acceleration is or the force is directly proportional to the displacement from the mean position over there. Then I am saying here, I'm using here for the explanation that as we know, according to Newton's second law, force is the F is equal to ma, and according to Hooke's law, F is equal to kx. Then if I ignore, I make A is equal to K over M into X, then always remember that the direction of this displacement taken will be directed towards mean position, shown with the help of negative sign over there, which I am showing here with a different color over there, that this is the negative sign available, which is showing that the acceleration is directly proportional to negative of the displacement, and displacement is always directed towards mean position over there. Okay. Now he is saying the graph shows the vertical displacement of a car body varies with time. Okay, it is a sinusoidal waveform over there to be shown. What he is asking over there, determine the maximum velocity of the car over there. So for the calculation of maximum velocity, I will have to take, first of all, I will have to go for time period. So I will say here that it is half wave, it is a full wave. Okay, 0.4 and time is measured in seconds. It is the time period which is being taken over there. So I will say here, first of all, I will have to go for calculation of omega there. Omega is, we know according to the relation 2 pi over time period t. So it is taken 2 into pi over time period, which I have calculated from the graph, that is 0.4 over there. That is 0.4. If I go with it, then I will say here 2 pi fraction introduced, 2 pi divided by zero point 0.4 is equal to 5 pi. Okay, then it is 15.707, which we can say 15.7. So it is 15.7 radian per second. And then we will have to take V is equal to R omega. V is equal to R omega over there. For that purpose, I am saying that if I want to calculate the speed over there, then what will be the R? R I am taking here in the form of amplitude over there, which I am saying it is in centimeter, and it is being taken from the mean position to extreme position over there. Then it is 3 centimeter. Then I'm saying it is being taken with the 3 multiplied 10 raised to power minus 2. I have converted this 3 centimeter into meters. Then I'm taking 15.7. Just go with it. 15.7 multiplied by 3 multiplied 10 raised to power minus 2 equals to 3 pi over 20. So it is 0.47 meter per second. 0.47 meter per second is the maximum speed over there. And remember that this R which I have taken is the amplitude, x naught omega. So V max can be calculated by using the relation of x naught omega, amplitude of the displacement, and angular velocity at that point over there. Now he is saying explain the damping. Damping causes the amplitude of oscillation of the car body to decrease over there. So we know energy is transferred away from the car body. Energy is transferred away from car body due to damping phenomenon, which is being caused because work is done against, because work is done against the resistive forces. So amplitude is going to decrease again and again. And here we can also add that the oscillating system of a car body is producing thermal energy by the dampers, and heat and thermal energy is being consumed in the form of dissipation due to resistive forces over there. All right, let's move to question number 16 over there. Here he is saying a food delivery company uses the ice packs to keep the food cold during delivery. Each ice pack consists of block of ice of waterproof bag. Each block is initially rectangular. Okay, length, width, height is given over there. Water of 0 degree centigrade is frozen. Okay, 25 centimeter, 1.5 centimeter thick over there. 15 centimeter. Okay, 15, 1.5, and 25. 25, 15, and 1.5. These are the dimensions of that rectangular frame over there. Okay, first of all, he is saying that water is at 0 degree centigrade frozen from the block of ice. The block is cooled. Temperature is minus 7.5 degrees centigrade. So, and then the block is sealed with a waterproof bag. Determine the energy transferred to form the ice block and reduce its temperature to minus 7.5 degrees centigrade. Density of the ice is 920 and specific latent heat of fusion of water is this, and specific heat capacity of ice is 2100. So first of all, I will use here the relation by using my first of all, I will calculate mass by using mass will be calculated in this form. Density is equal to mass over volume, which I will say mass will equal to density multiply volume there. Mass, when mass will be calculated, then I will use the simple formula of the heat transfer that we take in the form of Q or in the form of change in energy will be taken at mc delta theta or delta T can be written as a change in temperature, specific heat capacity, and mass over there. So for the whole purpose, now I am putting the values over there where I am saying that first of all, I will have to go for mass where density and volume should be taken. Okay, density of the ice, which I will have to take, that is 920. You can check over here that the density of the ice is 920 over there. 920 multiply volume, which I am saying 25, multiply 10 is per minus 2, multiply 15, multiply 10 is per minus 2, and it should be multiplied by 1.5 multiply 10 is to power minus 2. What I said about volume over there, length multiply width multiply height, and every dimension is converted into meters over there because SI base unit of length is meters over there. Okay, let's go for calculation over there that he is saying 920 multiplied by 25 multiplied by 15 multiplied by 1.5 multiply. I'm just joining minus 2 minus 2 minus 2 with 10 raised to power minus 6 over there. Power minus 6 over there. So this is the mass. 35 is the mass. 35 kg will be much larger over there, by the way. 10 raised to power minus 6 I have taken. I have put some value in the form of wrong wave. Let's check. 10 raised to power minus 6, 1.5 was being taken as a multiplication here. And I will have to go for its decreasing. Okay, now check. 207. So it is 0.51 kg, 5175518. So I'm taking 0.518 as my mass of that ice cube over there. 0.518, and then specific heat, latent heat of specific heat capacity should be being taken over there. That is 2500. 2100, sorry, it is 2100. I'm placing the values in red color, okay? 2100, 100 over there, and then delta theta was change in temperature, and change in temperature, even though that is given in 7.5 degrees centigrade, but it is change in temperature. And if we observe degree centigrade or we observe the theta in Kelvin over there, the difference will staying the same over there. I'm not using this minus sign because 0 to minus 7.5, 0 minus 7.5 will give me 7.5 as change in temperature over there. Just go for it. 0.518 is already written, okay. Multiply by 2100, multiply by 7.5. This will be your energy, which is being provided in the form of energy change over there. That I will say it is coming 8150. 8150 joule is the energy which is provided. Determine the energy transferred from the ice block and reduces temperature over there. Then for this one, I will say you will have to add its value with 8150 is the value for your this mass, and it should be being also being added with the latent heat of fusion over there. So I will also have to take the energy for latent heat of fusion, where I am taking the mass should be being multiplied like 0.52. Ice is melted, then I will have to take 3.4 multiply 10 raised to power 3.4 multiply 10 raised to power 5 over there. And this energy answer should be being added with 815 over 0. So I am saying here, go with 0.52 multiply 3.4 10 raised to power 5. So 0.52 multiply 3.4 multiply 10 raised to power 5, 10 raised to power 5 over there is equal to this. It should be added with 8150, and you are getting this answer, which is being taken as 1, 2, 3, 4, 5. 1.8 multiply 10 raised to power 5. 1.8 multiply 10 raised to power 5. I have just added this value which was for change in temperature and this value which was for melting of ice of 0.52 kg over there. Let's go for the next part over there where he is saying the website of the delivery company includes the following statement. If the ice has melted by the time you receive your delivery, this means that the energy from the ice has been used to keep the food cold. Explain why the statement made by the company is not correct. Is not correct. So I will say that latent heat energy must be supplied to melt the ice. Latent heat of fusion, latent heat of fusion must be supplied to melt ice, to melt ice over there. And in that case, we can say energy has been transferred from the food or surrounding to the ice. So energy has been transferred from food to the ice to melt it, to ice to melt it. So the company statement, if the ice has melted by the time you receive delivery, this means that the energy from the ice has been used. No way. Energy has been taken from the food. So this was the right statement correction over there because the company statement is wrong in that case over there. Okay, let's move to the next over there. What he is saying over there. This is the question number 17, where he is saying that the Geiger globe is the three-dimensional model of the Earth. Okay, the inflated globe is suspended from the above and is able to rotate. All right. The globe is filled with nitrogen gas. All right. When fully inflated, the globe has a radius of 3.5 meter. So calculate the mass of nitrogen gas needed to exert a pressure of this at the globe at temperature 22 degrees centigrade, which I will have to convert it into the form of Kelvin temperature over there. And then he is saying mass of nitrogen molecule is taken as this over there. So I will have to calculate the mass of nitrogen needed for it. For this one, I am using the formula of general gas equation over there, which will be taken according to PV is equal to NKT over there. PV is equal to N. No, I am taking N as capital letter. N K as Boltzmann constant, and T as temperature over there. So for this whole purpose, I will say here, first of all, I will have to go for calculation of this volume. Volume is being shown in the form of sphere 4 by 3 pi r cube over there. So I will say here 4 by 3 multiply pi into r is being taken as 3.5 whole cube over there. So go for it. 4 by 3 pi 4 upon 3 multiply pi multiply R cube means 3.5 cube is being taken. So the volume is, this volume is 179.6. Okay. 179.6 is being taken over there. And if I take the mass which is being provided, so mass I want to calculate, all right. So for that purpose, I will say here that I am using the relation of PV is equal to NKT. I'm using the math over there. Okay, for that purpose, first of all, I will go for calculation of this N over there. N is equal to PV over KT. P is given in the form of pressure 1.12 10 raised to power 5, 1.12 multiplied 10 raised to power 5 into volume, that is 179.6 divided by uh, the K as a Boltzmann constant, which is 1.38 multiplied 10 raised to power minus 23. This value is given also in the insert if you check into the formulas and constants with their values given in the sheet over there. Okay, then he is saying that should be multiplied by 22 should be added to 273, and 273 divided plus 22. 3 plus 2, 5, 9, 295. 295 over there. Let's go for its calculation now. First of all, introduce the fraction. He is saying 1.12 multiply 10 raised to power 5 multiply 179 multiply 179.6 divided by 1.38 multiply 10 raised to power minus 23 multiply by 295. 295 is equal to this. So it is being taken as 4.94 multiplied 10 to the power 27. 4.94. So n is equal to 4.94 multiplied 10 raised to power 27 over there in the form of number of molecules over there. Now I want to go for calculation of mass of nitrogen. So this number should be multiplied by this mass. So I will have to just multiply it 4.67 multiply 10 is from minus 26. So I'm just multiplying it here. Multiply 4.67 multiply 10 raised to power minus 26 minus 26 there is equal to 230.7 230.7, which I can approximately take 231 kg over there. So this is the mass of the nitrogen which should be filled into that globe, like inflated globe over there. Okay, what he is saying in the next part, the globe rotates with an angular velocity, means omega is given over there. Calculate the time taken for the globe to make one complete rotation. So time period is equal to 2 pi over omega. This is the relation. 2 pi divided by omega is 2.76 multiply 10 raised to the power minus 2. So go for it. It is being taken as 2 with pi divided by 2.76 multiply 10 raised to power minus 2 there. And yeah, it's fine, is equal to 277.6. 277.6, and time is measured in seconds over there. All right. Now he is saying that a solid sphere has the same diameter as a Geiger globe. Okay, solid sphere. calculate the mass of the sphere that would give the value of G at the surface, at its surface 9.8. So I am taking here the relation where I am saying I'm using the relation by using my value of I'm going a little bit derivation like G M over R square. Then I am taking equal to weight, gravitational force equal to weight over there. Mass is cancelled. Now I have got my G as G is equal to Gm over R square. Now if I take here, make this M as a subject over there, then I am saying here that because he said calculate the mass of the sphere. So mass is equal to G R square over capital letter G over there, which is the gravitational constant. So I can take here 9.8 multiply, radius was 3.5 meter, 3.5 square divided by 6.67 multiply 10 is to the power minus 11 over there. Let's go for its calculation a little bit just by putting into the calculator. Okay. Now, first of all, fraction introduced 9.8 multiply 3.5 square divided by 6.67 multiply 10 raised to power minus 11 there. So it is having the value 1.79 10 is to power 1.8 10 is to power 12. 12 and SI base unit of mass is kg over there. Let's move to question number 18 over there. Okay, he has said that luminosity is being given. The Hertz Russell diagram shows the relationship between luminosity and the surface temperature of a range of stars. Okay, this is the luminosity, the surface temperature in Kelvin, and the luminosity is there. All right. Now he is saying the sun is the main sequence star. Label the position of the sun on the diagram with letter S over there. So for that purpose, I will say that the sun marked with luminosity will approximately equal to 1 within the marked in man sequence region. And then man sequence region is being taken. If I take it is 1 is being taken like this. And I know that this will be the temperature which should be being taken, and because 6,000 Kelvin approximately above like this, then I will say here the approximate region for the sun location over there will be like this over there. Then he is saying in the final stages of the sun's evolution, it will become a white dwarf star. All right. Draw the diagram, a possible path of the sun. It evolves to a white dwarf star over there. So for this purpose, I will say here white dwarf. It should come over there from the surface of sun. So I am taking from this point as a central point over there. It will be, I say it will come back towards I will say low intensity for greater temperature over there. Then I will say it will go first up to convert over there, like in this direction, and then it will come back to make a white dwarf star over there, because we know that that the arrows needed to show the direction, and arrow for their position of the sun to a red giant region over there is being taken. So line from red giant region to a white dwarf region is being coming. This is the red giant region and this is the dwarf region over there. So white dwarf has been produced over there. Okay, let's move to the B part. Okay, this is the hysteric part over there. This is, I will say that explanation is required for this. Describe the stages in the evolution of the sun from the main sequence star to a white dwarf star over there. So I will say here that how the sun is going to be produced over there. then I will write about it that first of all, as we know, sun is made up of hydrogen. So I will say hydrogen is being fused in the core of sun. Hydrogen is fused in the core of sun over there, in the core of sun. And when hydrogen in the core is used up, and when hydrogen in the core of sun is used up, sun is used up over there at rate of fusion decreases, and in the result, the rate of fusion decreases, rate of fusion decreases over there. This is the main point, that when you are saying that the hydrogen is fused, and like helium is being produced over there by the fusion reaction which is happening over there, rate of fusion will decrease over there, and the core collapses under gravitational forces. In result, and we can say that core collapses under gravitational forces. Core collapses under gravitational forces over there. And in that case, then I will say temperature will rise and helium fusion starts. And temperature will rise and the fusion of helium, or we can say formation of helium, or helium fusion starts, and will rise, and fusion of helium will start over there. And in result, I can also add over there that the sun expands into a red giant, and sun expands into a red giant over there. And in that case, when no further fusion takes place, core collapses into a white dwarf. And when no further fusion happens, then the sun, or we can say then the core of sun or star, then core collapses, then core, or then star or sun, then star collapses into a white dwarf. I think so the whole concept which I explained step by step, it will be cleared for you. Okay, let's move to the C part. Explain why the sun will stay on the main sequence for a much greater time than the most massive main sequence stars over there. So I will say here that massive main sequence stars have much higher temperatures than the sun over there. Here I am adding two reasons for it. I am saying here as massive as massive massive man sequence stars have much higher temperature than the sun. This is the one reason that the sun will stay in the main sequence over there. And hydrogen is fused at a greater rate over there than in the sun. Then in the sun over there, in which we can say here that so the time spent on the main sequence is less over there. So these were the reasons for this question over there. Let's move to question number 19 over there, where he is saying Tau Ceti is a main sequence of stars similar to the sun. Several planets orbit like Tau Ceti. The spectrum of electromagnetic radiation emitted by Tau Ceti has maximum intensity at a frequency of this hertz. Show that the surface temperature is this. So for this one, I am using here, first of all, I'm using here the calculation of wavelength, and then I will use it by using temperature calculation. I will go for maximum wavelength multiplied by temperature over there. Let's go for its calculation. First of all, as we know, according to the simple waves formula, V is equal to F lambda. I want to calculate my lambda over there, which will be V over F, and electromagnetic waves have the speed over there that is equal to speed of light, 3 multiplied 10 raised to power 8, and the frequency is 5.5 multiplied 10 raised to power 14. Let's go for it. Fraction introduced, 3 multiplied 10 raised to power 8, 10 raised to power 8 divided by 5.5 multiply 5.5 multiply 10 raised to power 14. 10 raised to power 14 over there. 3 multiplied 10 raised to power 8 equal to this. So the value will equal to 5.45 multiplied 10 raised to power minus 7. 5.45 multiplied 10 raised to power minus 7, and the unit will be in meters per wavelength over there. And if I use the relation with respect to its relation with the lambda max is equal to T is equal to a constant, then we can say it will be taken as lambda max multiplied T is equal to a constant which is 2.88, 2.88, which is Wien's displacement law. According to that, this is the Wien's constant over there, 2.898 multiplied 10 raised to power minus 3. Now I am putting this wavelength which I have calculated there. I will just divide it by that. So temperature will equal to 2.898 multiplied 10 raised to power minus 3 divided by 5.45 multiplied 10 raised to power minus 7 there. So let's take it and make the ratio over there. All right. So I'm taking the above and divide by answer over there. All right. 2.898 multiply 10 raised to power minus 3 power minus 3. Okay. And I will have to put brackets so that it can exactly come over there answer in the form of that. Divided by answer. Divide answer will give me 5313. So it is exactly like 5300 Kelvin. 5313 will be used as a temperature over that surface over there. 5313. 5313, which is approximately equal to 5300 Kelvin over there. I think so the concept behind it, you are done with it now. Let's move to part second, which he is giving there. Okay. Now he is saying calculate the average kinetic energy of gas atom at the surface of Tau Ceti over there. Okay. It means I will have to take the intensity formula that will be related, first of all, area of the whole sphere over there will be taken as surface area, 4 pi r square. This is the formula. If I use my luminous intensity is equal to Wien's constant, with cross-sectional area with temperature power 4 over there. Then I can calculate here the luminosity. Then I will use here for the luminosity. Then I will use here for using this luminosity. I will say I will take intensity also. Intensity will equal to luminosity over 4 pi d square. If I arrange both of these formulas by putting their values into them, then I will say it will give me the notation for intensity, because I need the average kinetic energy. Then I will use it with the power to be used over there. Let's arrange it first for intensity to calculate that. Then I will use luminous intensity on the surface, and that power with the kinetic energy can be measured in the form of average calculated value that will be compared with its original value over there. Let's go with it. Let's take intensity is equal to uh, 4 pi r square, can be taken as 4 pi r square luminosity. 4 pi r square, I have taken the area over there, area in this. Then I have Wien's constant and have the power T4. This is whole luminosity is being taken above, is divided by 4 pi x square over there. 4 pi d square, I'm taking x square in the form of diameter over there. Okay, just put all of those values which are provided to you for pi. And for radius, I am using the value here for the radius. For the radius, 5.45, okay, 5.45. For the radius, I am using here 5.45, 5.52. Wait a second there. Okay, it is given here in the form of 5.52 multiplied 10 to the power 8. Okay, that is the value which I am taking. No, I am to go for energy over there. Why I'm using this? I'm editing this all. Wait a second over there. I'm not using the luminous intensity. I will use for gas temperature only the relation of kinetic energy with the main resolution of the question. I'm not using this. Wait a second. This whole will I will use for the next part. Sorry, it's my bad. No problem for it. Let's go now. Okay. Now what I'm saying, I need kinetic energy. I'm using the kinetic energy formula over there. That is half m average kinetic energy with the speed c square over there is equal to 3 by 2, and will be used with Boltzmann constant k and temperature T over there. And I will use average kinetic energy over there. For that purpose, 3 by 2 multiply Boltzmann constant value, that is 1.38 multiply 10 raised to the power minus 23, and the temperature which I have calculated the 5300, or I can take 5310. For average kinetic energy, just place all of the values into the calculator. 5313, okay, multiply 2 by 3 is 1.5, multiply 1.38, multiply 10 raised to power minus 23 equals to 1.09. 1.09 multiplied 10 raised to the power minus 19 joule over there. This is the average kinetic energy of the molecule, which is half mc square. I am saying this is kinetic energy over there. Okay, let's move to the next part over there. Now here I will use the radius of Tau and etc over there. Aita is a planet in the orbit around Tau Ceti. A scientist suggests that Aita receives a same intensity of light from Tau Ceti as the Earth receives from the Sun. Okay, evaluate the accuracy of suggestion. Radius of Tau is this. Distance between Aita and Tau is 8.5 10 to the power 5. 10 is power 10. Intensity of the light received is 1360 watt per meter square. Okay. Now I will have to use the intensity. First of all, area of sphere, I'm saying 4 pi r square should be taken. For luminous intensity, it is being taken that in luminous intensity can be taken as Wien's displacement constant. After that, I'm using cross-sectional area with T power 4. This is the formula for luminous intensity over there. And then I will say the intensity is equal to luminous intensity over 4 pi d square. 4 pi d square. This is the whole relation over there. Now I am putting the area in the place of this. Now get the intensity is equal to, I'm replacing this L also. I'm writing here Wien's constant with cross-sectional area 4 pi r square with T power 4 over 4 pi d square over there. Now, d is the distance and r is the radius. So radius of tau is coming here and the distance is coming down over there. 4 pi is cancelled with 4 pi. Let's check what is remaining over there. So Wien's displacement constant is 5.67. 5.67 multiply 10 raised to power minus 8. After that, 10 raised to power 5.67 multiply 10 raised to power minus 8. After that, r square, r is 5.52. 52 multiply 10 raised to power 8. And it should be taken in the form of square also with temperature power 4. So I will take 5310 power 4 divided by d square. D square is being taken as a distance over there. So I will say you will have to take 8.05. You will have to take 8.05 multiply 10 is power 10. 8.05 multiply 10 is to power 10 and go with power 2 over there. Let's go for its calculation. Your intensity will be there. Let's check. 5.67 fraction introduced. 5.67 multiply 10 raised to power minus 8 there. And also being taken over there, 5.52 bracket start. 5.52 multiply 10 raised to power 8. Power 8 bracket close whole power 2 square now power 2 and being taken with multiply 5310 whole power 4 divided by bracket start 8.05 multiply 10 raised to power 10 raised to power 10 there multiply by not bracket should close and take the square over there. So it will equal to 2119. It is equal to 2119. That is much larger. Okay, intensity I have calculated all right. 2119, which I can say 2120 watt per meter square. Then I will say that it is much greater according to this given value, that is 1360. So I will say it is inaccurate. Inaccurate over there can be taken into account. So you can also say that the suggestion is incorrect for this calculation over there. Let's move to question number 20 there. Okay, where he is saying that the space of Probo Galileo was sent into the study the planet of Jupiter. The space probe was powered using plutonium-238 to 38 decays to an isotope of uranium by emitting alpha particle. Okay, so alpha particle should be 4 over there, should have 2 over here. So it is 238, so it is 234. 92 plus 92, it will be 94 over there. I have just completed the balancing on both sides over there. Okay, what he is saying over there now, the space probe was powered by the energy released from the decay of plutonium-238. Show that the energy released in the decay of the nucleus of plutonium is 5.7 mega electron volt. Mass of plutonium nucleus is this. Mass of uranium nucleus is this. Mass of alpha particle is this. So first of all, I will have to go for the measurement of change in mass as a mass defect over there. For that purpose, I'm taking the product mass over there first, like the masses which are given in the form of, I'm saying the mass of uranium plus mass of alpha particle, then I will subtract the combined mass of plutonium nucleus over there. So 3.8851 multiply 10 raised to the minus 25 plus 6.6399 multiply 10 raised to the minus 27 should be subtracted with 3.9516 multiply 10 raised to the minus 25. Let's go with it. Bracket start 3.8851 multiply 10 raised to power minus 25 is being coming like this, plus it means I will have to take another bracket over there. I will have to go for another bracket over there. Okay, it is starting, and now I'm taking it towards what is this? Bracket close, and after plus, I am just starting the bracket again. That is 6.636399 6.6399 multiply 10 raised to power minus 27 and bracket close minus 3.951 and bracket should start over there. Start 3.9516 multiply 10 raised to power minus 25 there, bracket close, and is equal to, means he is saying minus 101 multiply 10 raised to minus 29, minus 1.01 multiply 10 raised to power minus 29 kg. And here you can remember that this minus can never be available over there because mass is not a vector quantity, it is a scalar quantity. So only take the magnitude, so ignore the sign. Then go with the Einstein's equation for the calculation of energy total over there. So binding energy per nucleon can be calculated 1.01 multiplied 10 raised to the minus 29 into 3 multiply 10 raised to power 8 whole square. Let's go with it, where I am saying, okay, it should be multiplied with answer. So I'm have to take bracket start, 3 multiply 10 raised to power 8, 8 bracket close whole square should be being multiplied by answer is equal to 9.09 10 is to minus 13. 9.09 multiplied 10 is to minus 13 joule. And if I want to go for the calculation in electron volt, if you observe here 5.7 mega electron volt, then I will say here that I will have to divide this energy by 1.6 multiplied 10 is to a minus 19. That is charge on electron over there. So I'm saying here this is being taken as, okay, fraction introduced 9.09 multiply 10 raised to power minus 13 divided by 1.6 multiply 10 raised to power minus 19 equals to this 1, 2, 3, 4, 5, 6. So 5.6 multiply 10 raised to power 6. 5.67 mega can be taken and energy will be taken as electron volt. So this is your binding energy per nucleon can be calculated by using this relation. I think so your whole paper is completed now, and best of luck for your exam, and kindly subscribe my channel so that the latest paper solutions you can find for all the subjects for sciences and mathematics over there. Thank you so much for today. Allah Hafiz.